Sit on your hands to keep from clapping. You are looking at the circle where degrees originate from. This diameter is equal to the square root of 4/3. And because degrees are originally lengths, and lengths are now originally degrees, we can look at this diameter 1.154700538 as a degree of bend. And if this pipe was bent that many degrees, just over 1 degree, I could study what this pipe would be doing as it rotated. And once I rotated it down to 30 degrees, it would be looking up 0.577350269 degrees and to the right 1 degree. When you divide the 360 degrees of the circle, simultaneously you are dividing the 360-inch hypotenuse equilateral triangle. See, the equilateral triangle leg is actually the 60-degree portion of the circle. And whenever you multiply the diameter times the equilateral triangle height, it will equal the equilateral triangle legs squared, linking the circle and the equilateral triangle as one. And also another cool fact, if you take the equilateral triangle height and multiply it by 1/3 of your circumference, it will equal the area of the circle. This is another thing they didn't show us, they hide from us, that every right triangle on the hypotenuse has 2 arches that perfectly fit on top of it that will add up to 180 degrees, and it's double the inside degree measurement. So this 30, 60, 90, the 30 degree mirrors 60 degrees of arc, and the 60 degree angle mirrors 120 degrees of arc that sit on top of it. And whenever this hypotenuse diameter, the 90 degree hypotenuse diameter, is 1 inch, this 30 degree opposite diameter is 0.5 inches. And whenever you square 0.5, you get 0.25, and that's this section of the ball right here, of the circle right here, and 1/4 of the diameter. And then whenever the 60 degree adjacent diameter, when you square this side, it equals 0.75. And that is this section of this circle and 3/4 of the diameter. So 1/4 plus 3/4 equals the 1.